So the third speaker is Dr. Luca Gianoli. So the title of his presentation is an ad hoc edge computing infrastructure for improved workflows, communication, and logistics in COVID-19 healthcare facilities. So I will play recorded video, and he will answer questions after this video. Before I play the video, let me introduce the speaker first. So in 2014, Luca Gianoli obtained a PhD degree in the electrical engineering at both Politecnico Milano and the Politecnico Montreal. In 2016, after 2 years as a postdoctoral research, studying cloud optimization method and ad hoc communication strategies for robotic swarms, Dr. Gianoli joined Humanitas Solutions. Sorry. So first as the ICT lead scientist and then as the CTO, Dr. Gianoli has been leading the company's R&D team. Under his leadership, Humanitas has developed a new edge computing architecture for smart robotics environment capable of providing cloud computing service under any situations. His research interests include network optimization, ad hoc wireless networks, cloud edge computing, embedded system, and drones. So let me play the video.
Good afternoon, everybody. My name is Luca Gianoli, and I am the CTO of Humanitas Solutions. First of all, I would like to thank the scientific committee of the event for inviting me to give this talk and for allowing me to be here also for the second edition of this wonderful event. Today, I will talk about this new ad hoc edge computing infrastructure that we have developed and we have deployed into an hospital out of Montreal in Longueuil, the Hospital Charles-Lemoine, with the goal of improving workflows, communication, and logistics for all the operations related to the treatment of COVID-19 patients. I also would like, before introducing our solution, I would like to give you some information about the vision of Humanitas. Our mission is that of developing what we call the emergency response ecosystem of the future. It's a system that will allow autonomous drones, autonomous robots, IoT devices, any kind of smart, let's say, devices to seamlessly collaborate with the emergency responders in the field, even in the more challenging conditions. For example, when no telecommunication network is available. And in this effort, we have been assisted by multiple Canadian universities and multiple international industrial partners that have been helping us to develop all the different blocks that will power this new ecosystem. The main ingredients of this new ecosystem is represented by what we call the DOME, so this distributed orchestration for multi-agent ecosystems architecture. A three-layer architecture that is made at the bottom by an ad hoc telecommunication middleware, in the middle by what we call the virtualization layer, which is a kind of Docker handler that allow us to run and manage Docker containers on any kind of embedded device. And then at the top, we find the distributed orchestration layer, so a software that allows us to deploy multi-container application on any set of heterogeneous devices. When we develop, when we are used to develop technology that will require the collaboration of multiple smart devices, so multiple smart devices that will be running this DOME architecture. During this process, what we do at Humanitas, we first test all the multi-agent applications into the HyperX space, which is actually the simulation, hyper-realistic simulation solution that we presented last year at the Buffalo Wearable Days. And when the simulation results are good, are satisfying enough, then we can use our orchestration technology to deploy the real application on the real hardware. So on all these smart devices that will be running the DOME architecture. They can be robots as smart devices. And since this technology is very general, we can target many different use cases, including the hospital use case. So for the hospital use case, the most important component architecture, let's say the hardware components of the architecture, is represented by a device that we call the Nano data center. It is basically a smart plug that can be plugged into an electrical socket. And the smart plug is basically made by a Linux onboard computers with 4 cores and 1 or 2 giga of RAM, 2 Wi-Fi interfaces, one configured in Ad-Hoc mode and one in access point mode, one microcontroller that is capable of sniffing Bluetooth and wireless signals, and other type of sensor that can be added through some extension. We have some plugin that we can attach to this data center. The data center is running the DOME architecture, and the idea that if you place multiple data centers within an area, like an indoor area, then we are able to deploy multiple applications that are Dockerized on top of them. It is really a kind of distributed local data center. And why I'm talking about another data center? Because this is really the main ingredients of this project that we started in March so this year. So this project that we are using to drive the digital transformation of this hospital in Quebec, so outside of Montreal, and the digital transformation that will allow right now to better deal with the second wave and for the COVID-19, and in the future to allow to improve hospital operations. In July, we were able to do the first deployment of another data center into the hospital, and everything was filmed also by a reportage on Canadian television. And really had to thank all the personnel of the hospital, the security guards that helped us, and all the medical personnel that have supported us through all these months of testing and development. And here I would like to show you the map of the ground floor of the hospital where we placed our data centers. There are 3 different areas in the ground floor where we placed the nodes. Now we have actually 54 data centers deployed. This part of the map represents the emergency area of the hospital. Then we have the core part. Here we have some corridors where people can come in, and then so there are other departments of the hospital that are not for the moment involved with the treatment of COVID-19 patients. And finally, on the, let's say, west wing, also on the left, we have the long corridor that then leads us to the what we call the short stay COVID-19 area, where patients with COVID-19 are kept with all the safety regulations that are necessary. And now, I thought that instead of describing what we did, the best way of showing you what this system consists was showing you a video that actually was made yesterday during a simulation that represents a standard transfer of a COVID-19 patient from the emergency area to the COVID-19 area. This type of standard is called the RED protocol, and we show how this our Nano data center infrastructure can be leveraged to run automated workflow supported by geolocation services that will allow to properly to improve the way operations are handled. You can see here we have so at the emergency area we have the head of the emergency area that will be responsible of starting a new what we call RED protocol. So the protocol that will allow the RED patient to be transferred to the COVID area. With this interface, we are able to select the tag, the Bluetooth tag that will accompany the patient, and then we will be able to contact the security guard that will have to accompany the transfer, and the stretcher bearer, that's so the person that will physically move the patient from the emergency response to area to the COVID-19 short stay area. You can see now we have launched the transfer. You can see on the walls you'll be able to notice the multiple Nano data center that have been installed along all the corridors. Now at the end of this corridor you will see there is a light. So with the Nano data center we are able to handle also in this case IoT devices. In this case there are smart lights that have been placed along the whole corridor. And when a red transfer is started, the lights are switched on with a very intense red color, so that people in the hospital will be alerted of the initialization of a red transfer. And now here you can see what can be seen by the emergency response boss that launched the transfer, and also by the second nurse that the second person that will be handling the transfer in the COVID area. Now you can see in this new map we can also see all the, not just the tags involved in the transfer, but also the tags that have been deployed within the whole environment. And also what will happen is that when now we see as the patient approaches the COVID-19 area, there is an area that is called the SAS area, which is a zone where basically the medical personnel has to transfer the patient on a stretcher that will never that cannot exit the COVID-19 area. And as the patient reaches this area, there is also this red light in the COVID area that starts blinking, so that the personnel in the COVID-19 area is notified of the presence of the patient in the SAS area, and so without losing any time, so without any delays, they are ready to start the transfer. And then, as you can see, at the end, this is not a real patient; it's a mannequin. Now, at the end, the head of the COVID area will confirm that the transfer has been completed, and so all the action have been registered into the database, and then we have a dashboard that will allow to show and to let's say to read all the relevant statistics concerning the transfer that we just the last time that was made. Also, we have also average statistics about all the transfers that have been made during the last days or weeks. So this is the end of the video. Now let me switch to the next slide. So to summarize, what are the main features of this new edge computing ecosystem that has been deployed into this hospital? So the ecosystem is completely wireless, and most of all, it is completely independent of any pre-existing network. That's why it was kind of easy for us to obtain even the permission to install it, because we didn't have to interact with any of the ICT infrastructure already installed at the hospital. We just had to plug the Nano center into the walls. And it's worth pointing out that we can achieve right now a bandwidth of 10 megabits per second among between the most distant Nano center within the area. So that are, let's say, 13 or 14 that are at a distance of 13 or 14 ports. As I was saying, it's totally plug and play, and so the network, everything is automatically initiated as the nodes are installed, and everything can be managed from remote. So both the infrastructure, so also when there are blackouts, we have to restart, and we can do all the troubleshooting from remote, and also all the applications, all the device application for geolocation, for the workflows, can be restarted and managed from remote through the orchestration platform. And it is worth pointing out that we can, so now we showed you through the video, we had IoT management application for the lights that was collaborating with the automated workflow application and with the real-time location system. But we have also a VoIP application where we have a SIP server that are running on data centers, and also we are going soon to showcase robotics application with robots that can be used for telemedicine, and the robot will be able to navigate within the hospital with the assistance of the Nano data centers. And also, we are able to, for example, manage multiple floors and to manage multiple sites because this infrastructure, thanks to the Ad-Hoc networking layer, to the distributed orchestration layer, it's ready for multi-site configuration. So to deal with multi-site scenarios. Well, also part of the application may run in the cloud, so not physically, for example, at the hospital. And we are also working right now to a new version of that center where we will have for sure also 4G and 5G extension, because if some of the nodes in our vision will be able to get global connectivity through 5G or 4G modems, and offering this let's say this wireless WAN interfaces to all the other nodes, and our networking software will be able to dynamically choose among device-to-device path or cellular-based. So thank you for your attention and for your time. And now I'm here to answer the questions that you may have. Thank you again.
It seems any questions from the audience, please? It seems there's currently maybe they are still typing maybe. So let's just again wait for the maybe you can answer their questions offline later. And but also thanks for again presenting today, and also here answering questions. Since I guess it's running late, so let's just move to the next.
Thank you.
Thank you.
Thank you, Tisun, and thank you, Zhang Yu as well. I see you.
Thank you, Luca.
Bye.